Alright, in this video I'm going to teach you guys how to solve radical equations. So these are the steps that you need to go through anytime you solve a radical equation. And I'm going to just talk about them a little bit right now, but they'll make sense more when we get into a problem. So I'm going to first isolate the radical. So that means get whatever is under the radical by itself and the radical itself. Then I'm going to raise both sides to the necessary power to get rid of the radical. I'll tell you what that means whenever we get to a problem. If there's still a radical, then you're going to repeat steps 1 and 2. These are for the harder kinds of problems. Then I'm going to solve for x and then check my solution. Alright, problem 1. We're going to start out pretty easy. So on this one, I've got to first isolate the radical. So first step is isolate the radical. So I'm going to add 4 to both sides. This is going to be x minus 10 equals 4. And so then next step is I'm going to get rid of the radical. So I'm going to raise both sides to the necessary power. To get rid of a square root, I'm going to have to square both sides. So then I'm going to get x minus 10 equals 16. And then to solve, I'm just going to add 10 to both sides. So x equals 26. Now, you do need to check your solutions. And you can do this on the calculator, or you can do it on your paper. A lot of times I think it's easier to just do your check on your paper rather than plugging it in the calculator, because a lot of this is easy math. So I'm going to go ahead and just check it on my paper. So I'm going to plug in 26. So 26 minus 10 and then minus 4 equals 0. 26 minus 10 is going to be the square root of 16. And so the square root of 16 is going to be 4 minus 4. So that's going to end up equaling 0. So that works. All right. Number 2, so this one is a little bit harder, but it's still not too bad. So first thing I'm going to do is isolate the radical. So I'm going to get this by itself and move the 3x over. So this is going to be the square root of x plus 1 equals 3x plus 1. Now to get rid of the radical, I'm going to square both sides. And so when you do that, you're going to have x plus 1 equals, and over here a lot of people like to just make this 9x squared plus 1, but you can't do that because this 2 means you have 2 of those 3x plus 1s. So I'm going to write that out again, and then I have to FOIL that. So I'm going to FOIL that out. 3x times 3x is 9x squared. The outsides give me 3x. The insides give me 3x. So when I combine those, that's 6x. Then 1 times 1 is 1. Alright. So then I'm going to go ahead and get everything set equal to 0 because this is a quadratic. So when I subtract this over, hey, will y'all shut the door on the way out? So when I subtract this over, this is going to be 9x squared plus 6x minus x is going to give me 5x, and then 1 minus 1 gives me 0, so that's just going to cancel out. And so then I'm going to factor out a GCF. So GCF here is going to be x. That's going to be 9x plus 5. And so then when I set both of those equal to 0, x equals 0 and negative 5/9. Okay, so this one might be a little bit easier to try to plug them into the calculator. So I'm going to go plug them in real quick. So I'm going to take 0 and store it for x, and then just type in my original equation. If it equals 1, then I know it's a correct solution. So I'm going to say the square root of x plus 1, and then minus 3x. So minus 3x, if that equals 1, I know it's right. So this one works. Let's check negative 5/9. So I'm going to say negative 5 over 9, stow x, and then second enter to pull up what I just typed. And so that does not equal 1. So that is not going to give me a solution. So x equals 0 is my only solution there. Alright, number 3. Now, this one is one that's a little bit harder. So you have 2 radicals that you need to get rid of in this problem. And so what you're going to do is make sure that you can't really isolate the radical on this one. So you need to make sure that you get the radicals on the same side. You get all the radicals isolated on the same side. So that's already the case in this problem, so I don't have to move anything around. So at that point, you're going to go ahead and, since they are square roots, you're going to square both sides. Now, the hard part about this is that when I square this is kind of like 2 binomials that I'm going to have to FOIL, okay? But it's not as bad as you're probably thinking. it's going to be. So I'm going to kind of show you what that is real quick. So I'm going to write it out twice because I'm going to FOIL. So when I multiply x by x, that's just going to give me, when I multiply the radicals like that, the square root of x times the square root of x is just x. It's kind of like the radicals just go away. So the outsides give me x, the insides are going to give me minus, and then I'm just going to multiply x by x minus 5, and I'm going to leave it like this. Okay? So then when I multiply the other insides right here, that's going to give me minus square root of x times x minus 5. And then my last is going to give me a positive. Square root of x minus 5 times square root of x minus 5 is just x minus 5. Now, I'm going to combine like terms that I can on that side. So I'm going to go ahead and combine my x and my x minus 5 here. So that's going to give me 2x minus 5, and then this is going to be minus. There's two of those radicals. So when I combine them, it's kind of like a -1 and a -1. That's going to be a -2 square root of x minus 5 equals 1. Now, this is where this other step comes in. If there's still a radical, so I've raised both sides to the necessary power. If there's still a radical, then I'm going to go back and repeat steps 1 and 2. So I'm going to go and isolate the radical again and then raise both sides to the necessary power. So let's go back and do that. So I'm going to isolate this radical. That means I'm going to get rid of 2x minus 5 and the -2. So when I subtract that over, this is going to give me -2 square root of x times x minus 5. Then I'm going to have -2x. And then when I add the 5 over, that's going to be plus 6. Now, I'm going to divide both sides by -2 to get rid of that -2 in front of the radical. So then those cancel out. I'm going to be left with x times x minus 5 equals, when you divide this right here, you have to make sure that you divide that -2 into both of the terms there. So -2 divided by -2 is just x, and 6 divided by -2 is -3. Alright, so now I'm going to raise both sides to the second power. Okay, and so then this is going to cause the square root to go away. So I'm going to be left with x times x minus 5. And then this, again, I'm going to write it out twice because I have to FOIL. So when I write it out twice in FOIL, that's going to give me x squared. The outsides give me minus 3x. The insides give me minus 3x, which is minus 6x. And then -3 times -3 is positive 9. And so then I just have an equation to solve now like we've been solving. So I'm going to distribute here. This is x squared minus 5x, and then equals x squared minus 6x plus 9. Since it's a quadratic, I'm going to try to get everything over on one side, but when I do that, the x squareds are going to end up canceling out, and so I'm going to be left with this. And so then when I add that 6 over, that's just going to give me x equals 9. Okay, so then if you want to check this solution, I would just store the value for x. Okay, or you can think about it. If I go back up here to my original, the square root of 9 is 3. 9 minus 5 is 4, so the square root of 4 is 2. So 3 minus 2 is 1, so that's going to work as a solution. Okay, we have 2 more. So number 4 is real similar as what we just did, except our equation is not set up for us like it was originally. Both of the radicals were on the same side in number 3. They're not in number 4. So I'm going to take this radical and move it over by adding it. So this is going to give me this equals 10. Alright, and then I'm just going to repeat what I did in the last problem. So I'm going to square both sides. And so that's going to give me something I need to FOIL here. So square root of x plus x minus 20, square root of x plus square root of x minus 20, and then it's going to equal 100. Alright, for some reason there it goes. Alright, so then I'm going to FOIL this. So the square root of x times the square root of x is just x. That, remember, the square roots kind of just cancel out. The outsides are going to give me plus the square root of x times x minus 20. And then insides are going to give me plus the square root of x times x minus 20. And then the last two radicals, square root of x minus 20 times square root of x minus 20 is just going to give me x minus 20. Woo, okay. So then I'm going to go ahead and combine like terms here. So let's do that. That's going to give me 2x from this x and this x minus 20 plus, when I combine these, that's 2 square roots of x times x minus 20 equals 100. Now I'm going to do the same thing I did on the last one and take the 2x and the negative 20 and move them to the other side. So this is going to be 2 square root x times x minus 20 equals a negative 2x. And then when I add the 20 over, that's going to give me plus 120. Alright, so then same thing that I did on the last one. I'm going to divide by 2. And that's going to leave me with x times x minus 20. Negative 2 divided by 2 is a negative x, and 120 divided by 2 is going to be 60. So this is what I have. And then I've got to square both sides again to get rid of that radical. So this is going to be x, no square root, x times x minus 20. And then when I FOIL this out, okay, this is what I'm going to get. So negative x times negative x is x squared. The outsides are going to give me a negative 60x. The insides give me a negative 60x. And then the last two, 60 times 60, is going to give me 3600. Okay, so then when I combine these, that's going to be minus 120x plus 3600. Okay, so then I'm going to distribute on the left side. This is going to be x squared minus 20x equals x squared minus 120x plus 3600. Alright, and so then whenever I go to write this or set it equal to 0, my x squareds are going to cancel out. And so then I'm just going to solve this. I'm going to add 120x to this side. And so that's going to end up giving me 100x equals 3600. And so when I solve that, I'm just going to divide by 100, and so x is going to equal 36. And then that solution is going to also work when you check it. Okay, last problem, and this one is much easier than the last two. You're probably saying, thank God. But a whole lot easier. So I'm going to isolate the radical. This is a cubed root. So I'm going to isolate the radical. 3x plus 1 is going to equal 5. And so then instead of squaring it like we've been doing, since I have a cube root, I'm going to square. Alright, so this is going to give me, since I have a cube root, I'm going to cube. I'm stupid. Alright, so then that's going to give me 3x plus 1 equals 5 cubed is 125. And so then I'm just going to solve this. So when I subtract 1, 3x equals 124. And so then I'm going to get x equals 124 over 3. And that does not reduce, but it does work. Okay, so if you store this for x and type this in, you should get 0 for your answer when you check it.